kulinariju.
Zdravo svima. Pre svega, kako da započnemo ovo predavanje, nego sa onim čuvenim, nadam se da ste dobro i da se čuvate. Izuzetno mi je drago što imam priliku da vas pozdravim ispred Google Developer Student Club University of Novi Sad, ovde u kompaniji Devoteam, koja je omogućila, odnosno čiji ljudi su omogućili da se ovo predavanje održi u koorganizaciji sa Google Developer grupom Novi Sad. Na sledećem slajdu, za početak, ja bih se predstavio. Ja sam Aleksa Komosar, ovogodišnji GDSC lead i ja sam odgovoran za sve aktivnosti kluba tokom ove godine, a naredne godine će me neko naslediti i preuzeti sve te aktivnosti. Pored mene, klub broji mnogo članova i klub ne činimo samo ja i moji članovi, odnosno core team, već i svi vi koji ste prijavljeni na zvaničnoj Google-ovoj platformi i hvala vam što ste dio kluba i verujem da će vam klub omogućiti mnogo toga, da proširite svoje znanja, da upoznate neke nove ljude i koliko vidim svi koji su dobili poziv i potvrdili svoj dolazak su i došli. Na sledećem slajdu možete vidjeti agendu i verujem da ste upoznati sa agendom, a to je da ću na početku pričati ja malo i to će biti minimalno, ne brinite. Nakon mene sledi Vanja Melnik koja radi business development za G-Cloud, ne samo za Srbiju, već i ceo region, a nakon nje će pričati Oliver i na kraju imamo jedno malo druženje gdje ćemo se svi bolje upoznati. I za sam kraj ja bih pričao o Solution Challenge-u. To je globalno Google-ovo takmičenje gde vi možete biti uključeni i razviti neku aplikaciju sa ciljem unapređenja zajednice. Sad, ja bih ovaj deo započeo sa onim kako nama naša profesorka Sonja Ristić na inženjerstvu informacionih sistema kaže, a to je da smo mi inženjeri odgovorni za živote drugih i često zanimanje inženjera materijalizujemo i mislimo da je inženjer neko ko zna da reši neku tešku jednačinu, a ovo takmičenje upravo vraća one prave vrednosti da biti inženjer znači biti i plemenit i pomoći svojoj zajednici. Google je na zvaničnoj njihovoj stranici izložio 11 globalnih problema gde vi kao studenti u timovima do 4 člana u svakom timu možete da rešite neki globalni problem. Ne praktično, već onako teorijski kroz neku aplikaciju, neki sitan doprinos, tako da vas ja podstičem da se prijavite. Sve informacije koje ne budete mogli pronaći na zvaničnom sajtu, budite slobodni da nam pišete na našim društvenim mrežama, a mi ćemo se potruditi da te odgovore dobijemo od Google-ovih menadžera i da ih dalje delegiramo vama. Što se tiče ostalih stvari u vezi sa ovim takmičenjem, možete pronaći na njihovoj zvaničnoj stranici, a ukoliko imate bilo kakav problem, ukoliko ne možete pronaći ljude za svoj tim, brine vas ideja, ne znate da li ste na dobrom putu, možete se uvek javiti nama u klub, mi ćemo vam dati neke povratne informacije, imamo dosta studenta koji su i na doktorskim studijama u klubu, tako da verujem da će biti jedno zanimljivo putovanje za sve vas koji se odlučite da budete deo ovog takmičenja. I još da napomenem da ovo takmičenje je powered by Google, odnosno svi menadžeri i developeri koji razvijaju tehnologije koje svi mi koristimo svakog dana će pregledati i validirati vaš rad i svakako da će vaš rad, trud i energija koju uložite u ovaj projekat da bude prepoznat. To bi bilo sve za moj ovaj deo. Ja bih sada najavio Vanju Melnik, koja radi svašta nešto i koja je radila. Ona će najbolje da se predstavi, ja ne bih da sad nešto pogrešno kažem, ali je ona odgovorna za G-Cloud, ne samo za Srbiju, već za ceo ovaj region, pa bih sada reč prepustio Vanji.
Hvala. Pa, dobar dan, dragi studenti, dobrodošli u prostorije Devoteama. Na Aleksinu inicijativu smo rešili da organizujemo ovaj događaj zajedno od pre nekoliko nedelja stigla inicijativa od Google Clouda da bi bilo dobro da Devoteam kao jedini premium partner Google Clouda u Srbiji postane zapravo organizator Google Developer grupe Novi Sad. Ono što ja želim da vas ohrabrim sve je da se priključite tim zajednicama. U Srbiji imamo Google Developer grupu Novi Sad, Beograd i Student Club, što Aleksa vodi, verujem da to znate i da ste već članovi toga, zato što i sve tri grupe u narednom periodu imaju planove za jako lepe edukativne radionice, predavanja, networking, druženja, na kojima bi bilo dobro da vi zapravo napravite neke svoje prve korake u tom putu karijere. Kada me Aleksa zamolio da nešto kažem o sebi, zapravo je tražio da mu pošaljem biografiju, ja sam ovako nabacala činjenice šta sam radila u poslednjih dosta godina i on je rekao baš ti je živopisna biografija, bilo bi super da nešto od toga ispričaš studentima. Tako da, ne znam ko je od vas pročitao, ja sam završila Prirodno-matematički fakultet, smer turizmologija i sad se verovatno pitate šta ona radi u IT industriji, verujte mi od marta se i ja pitam isto. Nije mi lako uopšte, ali je vrlo izazovno i jako rewarding, što bi rekli Englezi. Tako da, moj neki put je bio taj da sam, u stvari šta ja hoću vama da kažem, voljela bih da vam prenesem neke ključne stvari iz mog iskustva koje vama mogu da pomognu kada budete aplicirali za prve poslove. Pre puno godina na mom fakultetu je došao poziv za stručnu praksu u Londonu i prijavilo se nas 100 i da su birali po ocenama, odnosno proseku i kvalitetu engleskog jezika koji sam ja tada imala, mene verovatno ne bi primili danas, ja ne znam da li bi primila neko kao što sam ja, ali postoji nešto drugo što u stvari menadžeri kada zapošljavaju traže i to nešto je tim menadžerima reklo ona će tu da ostane i opstane i ja sam tako godinu dana u Londonu pretvorila u 10 godina prelepog života tamo, građenja karijere i sećam se u prvih par meseci kada sam radila na entry levelu unutar te jedne divne hotelske korporacije, viđala sam sa druge strane lepe, sređene, negovane, spuštenom kosom, namazanim noktima, sve ono što devojke na recepciji nisu mogle da rade, kako dočekuju klijente, imaju sastanke, ceo dan sede, jedu tamo u onim restoranima i piju i kao zezaju se, u stvari sklapaju poslove. Ja sam poželjela da budem direktor prodaje i taj put je meni, za taj put da stignem dotle trebalo 6 godina. Tako da nemojte nikada da posustanete i da mislite da nešto ne možete i da nemate dovoljno znanja i iskustva. Svaka objava za posao koja se pojavi ima toliko stavki, naročito danas, da vi bi verovatno rekli ja to ne znam i neću da se prijavim. A u stvari treba da se prijavite, jer često ljudi iz menadžmenta traže neke druge kvalitete kojih vi možda negde niste ni svesni. Jedna stvar koju sam naučila od moje direktorice je assume, svi znate šta znači. Ili ima neko ko ne zna šta znači assume? Ili presume? Ili podrazumevanje. I ona je nama jako davno rekla you never assume because assume makes an ass from you and me. I to je nešto što je nama koji smo bili u njenom timu jako značilo i dovelo nas je zaista do nekih impresivnih karijera. Da skratim tu priču, ja sam u hotelskoj industriji bila dugo i od toga, od početne pozicije do direktora prodaje i marketinga, na kraju do snimanja svoje firme i rada na globalnom nivou, sam se sad zadesila u Devoteamu i to ne samo Devoteam, nego Devoteam G Cloud, što je, možda se pitate kao pa dobro zašto ako je ono bilo tako impresivno, zašto si sad tu, nažalost desila se korona, malo je usporila taj biznis i ja sam se našla u situaciji početkom ove godine da nisam mogla zamislim da prođe još jedna godina da ja ne radim ništa, tako da sam došla do Devoteama i kada je Stevan meni prezentovao šta bih ja tu mogla da radim, odnosno njegova ideja je bila upravo ovo, da širim znanje, odnosno to što G Cloud jeste da prenosim u Srbiju kroz svoje strategije, poslovno, prodajno, marketinške, da bi ja njemu rekla moram da razmislim. I on je mene pogledao, znači rekao Vanja, u pitanju je Google. U tom trenutku meni kao nekome ko nije iz IT sveta to baš nije puno značilo, za mene Google je Google Search i Google Map i tu se negde moja ideja završavala, ali posle evo 9 meseci, što je negde period kada se izgradi jedno malo ljudsko biće, koje savršeno funkcioniše. Mi smo došli do toga da pored titule koju imam za business development, za Adriatic, prvo je krenulo od Srbije, pa se to sad širi na Adriatic, je odjednom sam postala lead za GDG Novi Sad. I ovo je prvi događaj koji radimo i meni je ogromno zadovoljstvo što je to sad urađeno ovako i jako mi je drago što ste se prijavili u roku od odmah, tako da nažalost nismo mogli da primimo sve koji su tu. Šta sam još htela da kažem iz tog karijernog puta je stvar koja je meni jako važna, to je umrežavanje i u tom smislu, znate šta znači umrežavanje, odnosno networking? To je ovo što vi sad radite, tako da umrežavanje, odnosno networking nama svima je jako bitan, ne mora značiti da ste iz prodaje i iz marketinga, tu rade ljudi koji blebeću ovako kao ja sada, znači i vi svi treba da se umrežavate, znači vaš domaći danas kad se ovo završi, spomenula sam Google Developer grupu Beograd, nju vodi Vladimir Jelić, upišite to ime, zapamtite, zapratite ga na LinkedInu, to je čovek, on treba da dođe u nekom trenutku, koji drži sve konce vezano za vašu industriju na teritoriji Srbije. Znači, njega kad zapratite na svim mrežama, dobijat ćete informacije gde se šta dešava edukativno. Druga stvar, kada budemo imali ovo neformalno druženje danas, nemojte da stanete i da pričate sa onim s kim ste došli, nego priđite kolegama s kojima nikada niste pričali i saznajte šta je njih motivisalo danas da tu dođu. Postoji u prodaji nešto što se zove elevator pitch. Jel znate šta to znači? I očekivano da ne znate, nisam znala ni ja dok sam studirala. Vožnja liftom traje svega nekoliko sekundi, minuta, kako god. I elevator pitch je kad se sretnu dvoje ljudi u liftu, da jedno i drugo znaju šta ovaj drugi radi, ali to, kad kažemo da znaju, to nije, na primjer, ja sad dođem i kažem ja sam Vanja i radim za Devoteam G Cloud, zato što onoj bakici što prodaje cveće, to ništa neće značiti. A ako ja dođem i kažem ja pomažem kompanijama da unaprede svoje poslovanje ili da utičemo na poboljšanje ekologije, na primjer, znači našeg životnog okruženja. To je ono što kroz Google Cloud i sad onda sledi pitanje, ta osoba će postaviti neka dalje pitanja, tako da možemo, kad smo već to spomenuli, da pređemo na ono što je Devoteam. Neki od vas koji su bili na Zlatiboru ste verovatno čuli Stevana, to je ista prezentacija, na malo drugačiji način ispričana za sad ove druge koji nisu. Devoteam je kompanija koja postoji 25 godina, ima preko 8000 zaposlenih u celom svetu. Jedna jako važna informacija koju se treba da zapamtite je da planovi Devoteama su da se taj broj udvostruči do 2024. godine. Šta to znači? Da ako ste vi sada na 3. godini fakulteta imate velike šanse da do 2024. godine dođete da radite kod nas. Takođe imamo jako veliki broj praksi organizovanih u toku godine, pratite stranicu, pišite na Instagramu ili bilo gde od nas da saznate tačno o čemu se tu radi. Devoteam kao takav je vodeća tehnološka kompanija koja zapravo tehnologija radi tehnologije nema nikakvog smisla. Ona nije ni prevelika, nije ni dovoljno mala. Dovoljno je velika da može da radi na projektima različitih multinacionalnih kompanija, a takođe je dovoljno mala da ne nameće svoje principe poslovanja. Ono što mi volimo da kažemo unutar Devoteama je da je tehnologija u našem DNK i to se nadovezuje na onu priču o pomaganju i unapređenju životne sredine, da mi zapravo tehnologiju, i to je vaš zadatak, to je Aleksa malo pre dobro spomenuo, tehnologiju koristimo da unapredimo svoje živote, živote svojih klijenata, svog okruženja i svega što je oko nas. Možeš dalje. Mi smo odlučili principi poslovanja Devoteama su se podelili na dva modela, a to je platformski način i studio model. Platformski način znači da smo se udružili sa 5 vodećih inovativnih kompanija na globalnom nivou. Tu su Amazon, Google Cloud i Microsoft kao public cloud i imamo 2 platformske kompanije Salesforce i ServiceNow. Studio model bi značio da svojim klijentima pomažemo da pređu sa projektnog načina razmišljanja na proizvodni, odnosno produktni. I to se radi kroz multidisciplinarne timove na agilan način, gde zapravo imamo ceo tim dizajnera, konsultanata, developera, security expert, data expert i ostalo, koji zajedničkim snagama zapravo vode klijenta kroz to, prvo ga prebacuju na cloud i onda ga vode kroz dalje putovanje njihove digitalne transformacije. I u tom smislu smo se, zaboravila sam da kažem jednu istu stvar, a to je da je Devoteam obećao sebi i svetu da će taj prihod, da će 50% prihoda od ovih kompanija koje smo malo pre naveli, da zapravo dolazi od korišćenja tih servisa. Tako da mi sa svima njima imamo jako blisku saradnju. Ja recimo na dnevnom nivou komuniciram sa različitim odeljenjima iz Google Clouda, odnosno ljudi koji rade iz Google-a. I to je ono što je meni jako uzbudljivo i kada me malo iznerviraju Devoteamu, onda ja kažem da ću da apliciram za Google zato što znam tamo ljude, ali vrlo brzo dobijem odgovor da nemam još dovoljno veština za Google Cloud da bi radila za Google, ali nema veze, možda ćete me vidjeti tamo jednog dana. Što se tiče 6 fokus serija koje imamo, to su ove koje smo naveli. Meni najdraža se odnosi na održivost, odnosno sustainability. I održivost u Srbiji, nažalost, nije na nekom zavidnom nivou, ali mi čvrsto verujemo da idemo u tom smeru i vi ste zapravo generacija koja to može da promeni. Kroz vaše, kada budete krenuli da radite, kroz neke vaše zahteve, želje, ideje, kreative, kako god. Ali ono što je bitno spomenuti da u zemljama, skoro u svim zemljama Evrope održivost je zaista na zavidnom nivou i to je ono na što se mi ugledamo i kada pričamo o tome, ja znam da mi radimo sa različitim cloudovima ovde, meni je najomiljeniji naravno Google Cloud jer ja stojim iza toga, ali jedna stvar koja njega izdvaja od ostalih je da je najčistiji cloud od svih. Tako da o tome možete malo da pročitate šta to znači i imaju jako velike ambicije i planove do 2030. godine. Tako da sve u svemu, ono što kada ja konkretno dođem do klijenta, skupim oko sebe tim konsultanata koji će da čuju klijentove potrebe i da predlože klijentu koje je to najbolje rešenje od svih o kojima sam pričala. Tako da mi njima zapravo napravimo predlog koja bi to bila platforma gde bi trebalo da se implementiraju, sve se to radi u cloudu i to klijentu zapravo pomogne da stvori nove digitalne, da prvo zamisli, a onda i napravi nove digitalne proizvode. Što se tiče samog Devoteam, ovo što sam pričala se odnosi na ceo Devoteam, tako da nebitno koja je vaša sfera interesovanja, verujem da možete negde tu da se pronađete. Što se tiče Devoteam G Clouda, imamo prisustvo u zemljama Evrope, sve ova crvena što vidite, i u Singapuru se nalazimo, u Indoneziji i u Meksiku, a Srbija je zemlja koja tek kreće sa time. Vi ćete negde možda videti da postoje na sajtovima nekih drugih kompanija da isto rade Google Cloud, ali zapravo Devoteam je jedini premium partner i to sa sobom nosi jako puno benefita. Imamo preko 350 Google eksperata, preko 2300 klijenata, 7 specijalizacija i ono na što smo najponosniji je da je Devoteam G Cloud izabran 2 godine za redom za partnera godine i mi predstavljamo managed service partnera za celu Evropu. Tako da, ja sam sad pričala kao navijena, ne znam da li sam nešto zaboravila. Znači, 2 domaća zadatka ste dobili od mene kao neko ko se bavi prodajom, ko prodaju obožava. I generalno ljudi ne vole prodaju zato što je ne razumeju na pravi način, ali prodaja nije ja ću tebe prodam šta ti ne treba, nego ću ja da prepoznam šta je to što tebi treba i samo te malo usmeriti, mada moji klijenti često kažu gde da potpišem, samo prestaneš da pričaš, tako da ja ću da sad se isključim. Ima još jedan slajd koji mi je omiljen, a to je da ja stvarno verujem da su all kids hang out in G Cloud i u to ime imamo Olivera koji je u UK. Jel se priključio Oliver, da ga dozovemo? Evo ga. Klikni na njegov slajd, sledeći. Tako da, Oliver Frolovs je Senior Google Cloud Platform Engineer iz UK. Oliver, I'm sure you understand everything what we said here.
Yeah, more or less. Some details might have been missed, but in general, yeah.
Wonderful.
I don't know. I don't know if you mentioned that we've recently acquired another specialty as well for Devoteam. It's via migration specialty. So we're collecting them like Pokemons.
Excellent. We need to update that slide. I wasn't aware. So great. Oliver, guys, thank you so much. Remember your homework. Go and talk to people you don't know. Ideally, go and talk to our engineers who are here, and they will join you later. Ask them what they do on a daily basis. Ask them whatever you want, and just remember there's no stupid questions. So Oliver, the stage is yours, and I will disappear now.
Thank you. Thank you very much.
Thanks.
Let me just take over the screen because I'm going to show some stuff, and then we'll. Let's see. Right. So you should be seeing my screen now. Hello, everyone. My name is Oliver. I live in the UK, and I was supposed to come to see you in person, but I got temperature on the day of flight, so you can't fly with a high temperature these days. So I couldn't come. Apologies for that, but I'm sure we'll have fun remotely. And what I'm going to talk to you about today is I'm going to talk to you about cloud computing and Google Cloud specifically, and why I think it's a good career choice. And also, basically, you can ask me anything you want, especially towards the end. So I'm going to be presenting some stuff, and if you feel at any point that you would like to ask something, please feel free to ask. And if it's something longer and you'd like a discussion, you can ask at the end as well. So I've been with Devoteam for about 3 months now, and before that I was a Go developer and infrastructure engineer. But overall, my background is basically in making computers do useful things. I not always worked in IT. I worked in other disciplines as well, but it was always with computers in one way or the other. I have my GitHub and my LinkedIn profiles on screen. So if you'd like to add me, please feel free. I post a lot of content on LinkedIn. So yeah, you can write to me on LinkedIn if you have any questions you do not want to ask, like in public as well. I'm happy to answer any questions. With that said, let's move on. So what are we going to talk about today is why would you care about cloud computing? Basically, it's a very important question. I'm assuming that most of you would be computer science students, or at least in some ways connected with computing. So I'm not asking you why would you care about computing. I think you have already decided that, most of you anyway, but why would you care specifically about cloud computing and not, say, embedded development, which was an interest of mine a while ago when I was at university. And basically, you can answer this question from two perspectives, from a personal perspective and from organizational perspective. And why organization would care about cloud computing is not the same why you would care about cloud computing. So for me, from personal perspective, I care about cloud computing because I think it unlocks opportunities for personal development. So you can realize yourself as a creative person, as an engineer as well, and at the same time it also allows you to have a rather comfortable lifestyle. It pays well, so it's it being an engineering discipline, it's more predictable than a lot of other creative outlets. If you do something creative, you do not necessarily have a good life. With cloud computing, if you like it, you'll do well in it, and so you'll have a good life. And this is actually not trivial. Not every arena of human life, not every area of human enterprise offers this combination. So you can fully realize yourself creatively. You can do creative stuff because it's engineering, and engineering is design, and design is creative stuff. So you'll be building things, making things, and at the same time you have a good quality of life. So I think it's amazing. From an organization perspective, though, why would organizations care about cloud computing? Well, the organizations would care about cloud computing because of this. Consider this. Suppose you work in a team or a small organization and you have an idea for a product or service, or maybe you are an entrepreneur and you have an idea, like you personally, about a product or service, digital product or service. So how would you make this idea a reality, because ideas by themselves, like dime a dozen, everybody has ideas. I have loads of ideas which I'm never going to implement, so who cares about my ideas? It's all about implementation. It's how you make things happen, how you build things. And imagine you have an idea, fantastic idea for some service or some product that you would like to trial out. So you write some code, but like, where would you deploy it? Like, how would you make it available to the people, basically, so you can start maybe selling them access to your service? In the old days, and that was around the year 2004, when I had my first job in IT, actually developing websites and managing Linux servers. This is how a server room in a small business would look like, quite literally. The company I worked for, it was a bit more tidy, so not as many cables, but the idea was this: if you wanted to run something, say even a website, right, what you would need to do is either convince somebody who had access to the servers in this rack to give you access to those servers and share the space with them like you would on a Linux system on the same computer. That was a hard thing to do because people didn't want to let you into their environment. They were afraid you would screw everything up because you didn't have separate, isolated environments. You just had this like Linux install and you had to share it with other people. Or, which is more likely, if these servers were over provisioned already, you would have to buy a new server, like an actual physical device. You would have to install it, find sockets for power, find sockets for network. You had to make sure that actually the network switch has enough sockets and capacity to carry this. So any idea that you had, any idea for a product, website, service that you had, would require you to actually provision hardware, which was very hard to do. And imagine if you work in an organization, if you want to run a small service, it's quite hard to get approvals, to get hardware, basically. And it's also a lot of money up front, a lot of money to risk. You would have to buy it at full cost, and then if your idea doesn't fly, maybe you'll have a spare server. But that's a lot of money to put up front, which is called capital expenditure, because you have to spend it all at once in the beginning. So that was quite hard to innovate with this kind of setup. Now, this all changed since that time, since 2004, so it wasn't a very long time ago. It all changed, and now you don't really have to buy physical hardware yourself if you don't want to. You can just use somebody else's hardware. You can use somebody else's hardware, and you can use it on very affordable terms. And the interesting thing about it is, how did that happen? Like, how did we go from here to here using other people's hardware and in such a short time span? And the secret here is virtualization. And I've made this slide to show you that virtualization as well, I mean practical implementation of it, is a very novel concept. Whilst you had some implementations of virtual devices in 60s, and there was some sort of small area of virtualization on mainframes in 70s, that means that a real physical device would present itself to the world as a set of similar or identical virtual devices, but it would all run on one actual physical device. It was not until 1999 that virtualization has become widely available on x86 platform, that is Intel CPUs. And the reason this is important, because 1999 was just before the dot-com boom. Internet was already going strong. It was big enough to be a serious force. And most of it ran on x86 on Intel CPUs. So prior to that, you had no decent means of having virtual machines. You have no decent means of virtualizing anything. And I remember when I started in my first job in 2003 or 4, something like this, we actually had physical server for every setup we wanted to do. So if you wanted to set up a Microsoft Exchange server for testing, even if you like use it to send 2 emails a day and that's all it does, you had to have a separate physical server. There was no other way to do it. Virtualization solutions were very rough at that point, didn't work with server versions or anything. So a first proper hypervisor, which is like a tool which allows you to run many virtual machines on one physical machine, was released around 2003. So Zen is a very popular open source hypervisor. It was only released around 2003. But then look what happened. As soon as virtualization became a real possibility, very soon you had a first cloud provider, which was Amazon, AWS. And they started in 2006. 3 years later, the first Intel hypervisor was released. And they only offered two services at the time. They offered virtual machines, which is EC Elastic Cloud, and they offered storage service, which was S3. So believe or not, in 2006, AWS, it was just that, just those two services, and they were not particularly reliable. And then 2 years later, Google Cloud opened its doors. But again, it was just a single service, Google App Engine, which was like a platform as a service. So it's like a environment in which you deploy your application, and a lot of things are decided for you already. So it's easy to get started with it, but it's not as flexible as having your own VMs. But this is how the cloud platforms have begun, basically, not very long time ago, right? So once we got to this idea that you do not have to have 10 physical machines to have 10 virtual machines, you can run 10 virtual machines on a single physical machine, and you provision and you manage these virtual machines using software, basically. You click buttons or you input commands, and bam, you have 5 Linux machines sitting on one physical machine. Once you started configure these things as code, or well, configure these things using programs, then somebody asked the question like, what if instead of you typing in the commands to give you a new Linux virtual machine and configure it, what if you had a program to do it for you? What if you write a program that configures a network for you, software-defined network? So when you have some physical network, which can be reconfigured via software, you don't actually have to disconnect and reconnect cables. And this is the concept of infrastructure as code. It only became prominent after virtualization has become prominent. And infrastructure as code, basically, it means this. You have your infrastructure described in some machine-readable format. So on this slide in the middle, you can't make out the individual words, but that doesn't matter. What this shows you, this is a file, a script, a program, you could say. It's about 100 lines long, right? And it uses infrastructure as code tool called Terraform, which is the most popular tool for this kind of thing. And in these 100 lines, this Terraform script provisions a whole Kubernetes cluster, a network behind it, and also certain complementary resources. So in 100 lines of Terraform, I can get myself a whole cluster of machines for distributed computing. And all of this is done in software. So this is incredible. Like in the old days, if you had to assemble the whole cluster of machines and make them behave, connect them by network, that's a lot of work. But here you can do it with 100 lines of code, and you run 2 commands basically, Terraform plan and Terraform apply, and you have it. You have your machines running, and you can deploy onto them, which is huge. Which means this could be an infrastructure for your startup. You write an application using Kubernetes, which is a container orchestrated platform, and you package your application into containers, and then you deploy containers onto this. And this could be like your first iteration infrastructure, so it would be improved as time goes by. But that would be a first start, and it's only 100 lines long, which is pretty cool. So, yes. So building infrastructure for your projects in 2022 has become a very, pleasant experience. Because first of all, you can have self-service. You don't need to talk to people. To use cloud platforms, you don't need to fill out long forms, get approvals. You can just click buttons, run commands, and you get the resources that you want. Second, with infrastructure as code, you can automate most of this away. If you need to set up 3 identical environments like development, test, and production, you can write a template once and run it 3 times, and you get your infrastructure. And also, and this is crucial, you only pay for resources that you actually use. Instead of having to buy servers like years in advance or months in advance and keep them all running, you provision VMs, you do the tasks they are designed to do, and you shut them down and you don't pay for them anymore. So you literally pay by hour or by minute or by gigabyte of data stored. So it's all pay as you go, which again makes starting out for small startups and every experimental project you can think of is a very, very, very affordable proposition as compared to what it used to be when you had to buy software upfront. Which means that if you have an idea for some product, or even just want to build a portfolio of things to show at job interviews, you can actually do that with public cloud providers. You can write your infrastructure as code in Terraform, right? You can put it on GitHub repository, and before your interview, you can run these Terraform commands and spin it up, show it to somebody, and shut it down and pay something like, I don't know, $1.50 for the whole experience. So it's not going to be expensive at all. And I think this is great. So what I wanted to show you, if we have the time for demo, is I wanted to show you this Kubernetes cluster. Or actually, maybe any questions before I do that?
Questions? No
I have
questions.
one question.
You have. Okay, we have one guy.
Mm-hmm.
Do you want to come
Microphone
here?
or-
Just come closer in case. I don't know if how to do this.
By the microphone or?
No, just you can stand here and
Right here. Can you hear me right now?
Yeah, I can.
Okay. So you talked about sort of how you got into cloud computing, but you didn't really say why. In a way, like what got you into this stuff? You mentioned creativity. You mentioned that the fact that you could build your ideas got you into it. But was there something else in there?
Well, basically, I was doing a PhD at university, which I didn't finish, and it was in dynamics and control. So I was working with embedded systems a lot. And I enjoy, in general, just fiddling with computers, building systems. It doesn't really matter to me whether it's an embedded system or a cloud system. And I originally had an affinity for embedded systems. But I looked at the job market for embedded systems and the kind of conditions in embedded market, and like the working culture of those companies. And we're going to this back to this topic again after the demo about the culture of the company. And I didn't like the embedded world because, well, the pay was low, the jobs were scarce, and also the companies were very old-fashioned, like traditional engineering companies with rigid hierarchies, like strictly office-based employment, no remote working, this kind of stuff. So I just didn't like it. And I said, okay, so what do I value in life? I value freedom and I value money. And I value the ability to express myself creatively in a certain way. So building things, that's how I express myself. So I looked at the landscape of computing and I looked for an area which allows me to be creative, which allows me to work remotely, which allows me to make good money. And it was cloud computing. And so I got into it and I loved it. That's basically why.
All right, thank you. And just another thing, you also, this is sort of curiosity, just, you said you worked in a place like 2004, whatever, when they used like more hardware to sort of keep their servers in check and stuff. And then they had to go from the hardware to more clouds and software stuff. So how much time did they actually need to like accept the change? Since you mentioned that it's pretty hard to accept those changes.
I'm not sure I understand the question. Do you mean the specific company? Because I worked in many places. It's just I started out in 2004. And when I started, none of these things were available. So like virtualization wasn't there. It wasn't ready.
Yes, but you mentioned that at the point when it was ready, they had to get from hardware to software, right? To clouds. And it was hard to like accept the changes. So how much time did they actually need to accept those changes and move on?
I wouldn't say it was a long time, because like if you look at the whole time scale of this thing, like AWS opened its doors in 2006. So how much do we have? Like, help me out, 14, 15 years? So, and that's like for the whole journey up to where we're now, where every cloud provider offers like hundreds of services and companies proactively use it. So I don't think it was a very painful transition. It's still happening though. The majority of workloads are still on on-premise data centers. And this is actually another point why cloud computing is a good area to get into, because majority of workloads, majority of IT budgets, IT spending is still in on-prem, but the pace at which they're moving into the cloud, either public cloud or hybrid cloud, a combination of private cloud and public cloud, the pace is accelerating. So you will see a lot more companies moving into cloud space in the coming years. So they are still working through this acceptance phase, so to speak.
All right, that's all I wanted to ask, so thank you.
Great.
Thanks.
Right, so how much time have we got, just to check?
Oh, we still have 25 minutes.
Great, okay, so let's try to run through the demo. So what I have here, reload.
Just 1 second, please.
Yeah.
Jel vidite vi od nazad ili da ugasimo svetlo?
Možete uvesti.
Znaš gde? Okay, you can continue.
Thank you. So what you're seeing now is a Google Cloud Platform console with a project opened. A project is like an accounting unit where all the other resources are attached to. And this is like a dashboard. So this project doesn't really have anything at the moment. It's an empty project. But what we're going to do here, you have various services which the cloud platform provides, and we are going to deploy a Kubernetes cluster. So we're going to create a network of computers, basically virtual computers connected by network, and configure it to run containers. And we're going to do it via Terraform. So if we look at this Kubernetes clusters list now, as you can see, you have no clusters. It's empty. And the next thing I'm going to show you, remember that 100 lines long Terraform thing that you couldn't see. So it's almost as this one, slightly different, but basically you have what, something like 100 lines of code, and it describes the things that you want in a declarative way. It actually doesn't tell how to make it. It just says that you want it. It says that you want, for example, to make a network in the cloud, and that you want to make a subnetwork in that network, and that you want to have a cluster, and the cluster is going to be geographically distributed across different availability zones. So this cluster would be resilient to failure. So if something happens, the whole data center goes down, the nodes in the other data centers will pick it up. It's fairly sophisticated, and it's like 100 lines of code. So the way we do this is I'm going to open something called a Cloud Shell, which is, again, like a VM, which Google creates for me. And I have like storage there. And I'm going to go to my folder where my example is. I've taken one of the standard examples and I've modified it slightly. So it's this thing here. And we basically need 3 commands. We need Terraform init, which is just for Terraform to download its libraries and plugins and what's not. It's just its housekeeping, basically, which is very boring because you just have to wait a few moments. Yeah, it's done. And now we have to ask Terraform to plan the infrastructure for us, because some resources have to be created after the other resources. When we write the Terraform configuration, we don't care about this stuff. We just say what we want. A Terraform figures out, infrastructure as code tool figures out the order in which these things have to be created. So if I go back to my terminal and I say Terraform plan, and I need to input some parameters, and I'm outputting this plan into a file which will later we will later apply. So what Terraform is going to do now, it's going to read this code which I had written, configuration, and then it's going to build a directed graph of things which have to be done first, and things that depend on them, and things that depend on them. And then it's going to basically display, this is the description of resources it's going to create for me. But the bottom line is it's going to create 7 resources for me if I run the apply command, which is exactly what I'm going to do. I'm going to ask it to apply plan, yes. And what it's doing now is connecting to the Google Cloud Platform via APIs, and it's going to provision the various services, which is going to take a while, about 5 to 10 minutes, I think. But we can talk about something else in the meantime. So it's already created a network in 10 seconds. Networks are fast to create. And then it's going to take a while to create a Kubernetes cluster. But once it's done, I'm sort of done with infrastructure. I can move into the world of Kubernetes at a higher level of abstraction, and I can deploy into Kubernetes and not to worry about infrastructure ever again. So while this thing is deploying, we're going to get back to it. I just wanted to talk about something how to choose a cloud platform, basically. Because I mentioned something about companies' cultures, and this is something that you won't find in, I don't know, technical comparisons, for example. So if you look, for example, at reports comparing different cloud platforms, such as Cockroach Labs, the makers of very interesting distributed SQL database, and every year they publish so-called cloud reports when they do like a lot of benchmarking, like bandwidth, throughput of network, CPU throughput, and they identify a winner among the three main clouds, which is Microsoft Azure, AWS, and Google Cloud. And in some categories, Google Cloud would be first, in some categories not. I think Google doing pretty well overall. But my point is, when you look at the cloud platform, don't only look at the benchmarks, also consider the philosophy and sort of ethos and origins of the company which the platform comes from. Because as an engineer, again, I'm assuming that you guys are engineers by your mindset. You want to be working with things which are well designed, which are designed like the way the engineer would design them for engineering purpose. And the thing about different cloud providers, if you look at the history of these companies, like Microsoft was established in 1975, and their main business is corporate software. If I remember correctly, for Microsoft, only Office and Windows ever made any money. So these are the money makers. The rest of the stuff Microsoft does never made any money at all. So they are proper corporation. And when they went into the cloud business, the Azure was established, I think, in 2010. So they're the sort of latest entry of all of these three. When they went into cloud business, they went into cloud business with a specific reason. They had customers who already were heavy users of Windows and heavy users of Office, and these customers wanted to have a public cloud platform. They said, we want to have a public cloud platform which integrates with our existing environments. So if, for example, you choose to specialize in Azure, you are going to see a lot of legacy stuff. You're going to have to do things in a way that traditional IT is doing things. There is, or at least there was a lot of things on Azure which you couldn't automate, for instance, like the Terraform code I've been showing you. It's getting better, but the main idea is it's like a proper corporate thing with large structure, and it's mainly built to accommodate the needs of large customers they have, which buy corporate Windows and Office contracts. So it's a big thing. AWS, you can read about it, Google it, it's interesting. AWS exists because Amazon wanted to save money on IT, because Amazon has this capacity, they're seasonal retailer, so they sell most around certain times of the year, and for the rest of the year the infrastructure just sits empty. And if I remember correctly, it was something like 80% of the time it just sits unnecessary, it's unused, but they only need it for a small fraction of the year. And they had this idea at some point, what if we start offering the spare capacity to other companies? What if we sell it like VMs and we can save some money? And this is basically what the driving factor behind creating AWS. They just wanted to save money, and it sort of went from there. But the main core business for them is not computing, not data. The main core business is retail. And again, the way they design things and the way their management, strategic leadership thinks about these things is going to be driven by the main business. Google, on the other hand, first of all, it's the youngest company of all three. And also it's company entirely driven by data. So Google is all about processing data, computing with data, storing data, transferring data in the most efficient way. So Google is data company, and data is Google's core business. And the driver for creating Google Cloud Platform wasn't so much to please some existing customers like Microsoft had, the customers with legacy technologies which they want to drag into the future kicking and screaming. And it wasn't to save money on data centers. It was to share the engineering know-how, the collective experience of Google engineers, which they have accumulated in running these distributed infrastructure as code systems. They wanted to make it available to the wider world. So it's a completely different ethos. And because of that, if you work with all three platforms, you will notice differences, like in how these philosophical differences will affect to how the platforms are implemented day to day. So for example, with Microsoft, because a lot of Microsoft systems administration is done using ClickOps, you just click and select options. You can't automate a lot of things still on Microsoft systems, although it's getting better. So that translates into their cloud. Amazon being stingy about something, that translates into their cloud. With Google, what you get is, first of all, it's less legacy. It's a new platform. It's designed after sort of the mistakes that had been made in the, say, the AWS had been avoided by Google because it's just a newer platform. But more importantly, it's open source friendly. They use a lot of either open source software directly or open standards, contribute to creating open standards. It's very API driven. Almost anything you can do, like in console or using ClickOps, you can do using automation as well with Google Cloud. Security. I think Google is the only platform, public cloud platform, which fully encrypts all data transmissions and all storage at all times. So security in depth means that at every level of the stack, there is something to help with security. I'm not saying that other cloud platforms are insecure. It's just because of Google. Google is a data processor, basically. Google works with data. They take security very, very seriously. And you will see this if you like get into the platform. And also another thing is with Google Cloud Platform, you have specialist machine learning hardware and workflows. Again, Google is very big on machine learning because they do a lot of machine learning for internal needs. They also make this hardware available to general public, which is pretty great. Yes, so that's why I think Google Cloud is a good choice for an engineer. Like if you're an architect and you're choosing a cloud platform for your organization, you might have different values. You might say, okay, like I have existing integrations with Windows. I'm going to choose Azure because I'm going to ensure that this is easier to integrate with what I already have. But that's like an architect choosing a platform for a solution. You choosing a platform to specialize in, you must maximize for happiness and for income. And I claim, that's my personal opinion, but I claim that with Google Cloud Platform, of all these three, you maximize for happiness because it's done by developers and for developers. It's very developer friendly. It's based on APIs. Everything is an API. Google has a very decent, very solid engineering culture in general, how they do things, how they manage change, how they introduce and retire APIs. So you would see a lot of maturity because before they started doing Google Cloud, they've been doing it internally for what, 10 years or more. So they know this stuff. They know this stuff. And to check on our, oh yeah, so we got our cluster up and running. So if we go back into our console, it's going to, so we have a cluster of 4 machines at the moment, 4 VMs, but this cluster is flexible. So if traffic grows, or if you want to deploy a lot of software on that cluster, it will expand automatically. And the interesting thing about this as well, these nodes are in different regions, so they're geographically distributed. So these would be different data centers. If the whole data center goes down, Kubernetes will still make sure that our application is accessible. So we're almost done with the infrastructure now. What we need to do now is we need to authenticate our new cluster with our tools so we can deploy on it. And for that, I'm going to run a gcloud command just to get authorization information from that cluster. Yes, and in principle, I should be able to view my cluster nodes from here. But as you can see, nothing is appearing, and I know why. This is because I wanted to show you how do you modify infrastructure using Terraform. This cluster is set up using security best practices, right? And it doesn't allow just anybody to connect to its admin control plane. And currently, this virtual machine I'm trying to access it with, it does not, it is not allowed to connect to the Kubernetes control plane. What we need to do is we need to update our configuration, and we need to tell it that this machine or this network is allowed to connect to the cluster. So I'm going to go into my Terraform configuration, right? And I'm going to add a new network, or a single node in this case, and I'm going to call it a Cloud Shell, which it is, so that I can actually connect to it. So again, I've changed my configuration, I've changed my infrastructure as code. I make a new plan, and you will see that the plan is much shorter now. It's just going to say, oh, this little thing has updated, I want to modify it. So look, it just says one resource to change, right? And pluses show that this is going to be our update. So all I've got to do is I've got to run Terraform apply this plan. And what it's going to do, it's going to call to Google Cloud Platform and make the change I've just requested. And remember, all this code for my infrastructure, I can keep it in Git, I can keep it under revision control, and I can have like a workflow for it to be validated and cross-checked by people or machines before it's being posted. So it's all very manageable. So you can actually design a pipeline which would deploy your infrastructure, and it would revert back if you don't like the change. So now I should be able to authenticate to my cluster and see I get a list of nodes. So we have a Kubernetes cluster up and running, and we can deploy to it. And the application we're going to deploy is this. It's Google's Cloud Platform demo. It's actually quite sophisticated. It's a microservice-based application, which means it's made of many little parts, each part doing its own unique thing. And the interesting thing about it is every part is written in its own language. So it's a very multi-language application. So there is Go, there is Node, there is Python, there is Java, and every component is built as a container, pushed into container image registry, and then you deploy it on Kubernetes as a container. And it also has these configurations. For Kubernetes. So if we go into microservices demo, so these are called Kubernetes manifests. They look a bit scary if you haven't seen them before, but they're just YAML files. And basically all they do, they describe various resources in Kubernetes, such as deployment or load balancer, for example, or something like this. And all it does, it says, well, for this resource, take this container image, and these are the configuration parameters. For this resource, take this container image, and this is this configuration parameters. So it declaratively links that thing together. It declaratively links this whole network of programs together and deploys them together. So what we're going to do, we're going to just run it. So kube control, apply, release, and again, this configuration, the way this application is configured, this manifest file you've just seen, the YAML file, I can store it in revision control, and every change I make is going to be revision controlled. But now it's going to be deployed, so let's just see. Let's just ask it to show us the pods, which is the Kubernetes unit of deployment. And as you can see, most of them are pending. So the Kubernetes would now get the container images, get the configuration, start container images, give them configuration, and watch them all the time in a control loop. So if some of them fail, it will restart them. If the whole node fails, cluster node, it will move these workloads to a different node. If there is too much traffic coming in and these nodes are not enough to serve this traffic, it will spin up new nodes, so the cluster size is going to increase. So it will heal them and it will distribute them in a way that is useful. So this is actually almost production scale infrastructure. If you had to do all these things yourself, without Kubernetes, without infrastructure as code, you would spend probably, if it's your first time, you would spend a couple of weeks just building a cluster together. So that would be a pretty challenging task. So it's going to spin up in a couple of minutes, and we're going to see the result of it. Yes, any questions while we wait?
Yes, we have questions. So, da dođeš ovde, molim te. Wake up, people. Stani tu, da može Oliver da te vidi.
Ovdje?
Da, evo tu. I okreneš se prema kameri, mahni Oliver, ne, njemu mahniš kameru.
Hi.
Evo mala vežba sa...
I have a question about this that you're showing us. 6 months ago, I did some project in distributed computing, and I had a problem with trying to virtualize and create, I don't know, like 5 nodes. So I decided to do it physically. I connected 4 computers and tried to make a distributed system. And this obviously is a solution to my problem. So I'm going to ask, how do you scale? I don't know, like add 3 or 4 nodes or maybe 100 nodes. And can you simulate like malicious nodes, or can you make some nodes that are connected, make the connection between them slow? So I don't know, you can benchmark how fast the packets between them are sent, or I don't know, like trying to make some.
I get the idea. Yeah, I get the idea. So the answer to all of these questions is yes. You can manage the number of nodes in your cluster. You can manage the number of pods, which are the units of deployment, so logical units. So they would handle the different volumes of traffic. You can measure the latencies and throughput of network. It's called network flow logs on Google Cloud Platform. So the network these machines are connected to, you can enable network flow logs on them using Terraform. So in practical terms, when we created this network, or even now, if I knew the parameters we need to use, you would add a couple of parameters here. You would rerun your Terraform configuration, and that would enable flow logs on your whole network, right? And then you can get those logs and analyze them. That would be good. Now, also with Kubernetes, because it runs a lot of nodes and a lot of pods on those nodes, if you taint some nodes, if you tell it that the node is not okay, it's going to redistribute the workload. So it's going to fix it for you. Also, if you want to slow down certain nodes, it's called chaos engineering. When you introduce some faults into the system in like a well-defined place to see what happens, and you can do that with Kubernetes as well. Yes, so you can basically throw a spanner into the network, so to speak. You can slow down certain nodes and so on. There is this company, I think they're called Gremlin. If you're interested in this kind of thing with Kubernetes, yes. So there is this company called Gremlin, and their whole business is about allowing you to do this mischief on your system, basically, including Kubernetes, and they have quite nice visualizations. So you can say what you want to do to your system, like slow down certain nodes, slow down traffic, disconnect a link, and stuff like that. And this discipline and this company is what you're looking for, basically. Yes.
Okay, and one more question. You can simulate payloads, like make some payloads larger, make some payloads smaller, and basically distribute the data between nodes and make the script and tell them exactly what to do and launch it on every node.
I don't know about Gremlin, but in principle, you can do that, yes, maybe using different tools. There are things like a load generator, something like Locust, for instance, load testing framework, yes. So I'm pretty sure you can make Locust do what you want, like whatever load profile you want to generate, Locust can do that. And the interesting thing about that, you can actually do it again in Kubernetes. You can have 2 clusters. One of them would be serving your Locust load, and the other one would be the cluster under test. So you have a production cluster or test cluster which you want to test. You spin up another cluster, and you can do it in that cluster. So let us check very quickly whilst we've been... Okay, so our pods, which are units of deployment, are all running. And so what I'm going to ask for, because I don't know the IP address it's going to use, it's provisioned a load balancer. So this is my external IP address. And usually, again, you can configure using Terraform or otherwise, you can configure a DNS name for it, so it's not a problem. But yeah, so this is something we've just deployed. So this is like a web application, and it's made of 10 or so different components. Some of them are like card components. Some of them are supposed to be showing ads, but I probably have an ad blocker installed. So yeah, the application is working. And look, it didn't take us a long time. So we had an infrastructure described, and I lifted most of the code I showed you, the Terraform code. I lifted it from the examples for Google Cloud Provider and Terraform. So you don't really have to write all of this yourself. You just need to understand what different options mean, and you change them to the values that you want. So it took us like 15 minutes to deploy the cluster, which is almost production grade. It's a very decent cluster. It's regionally distributed cluster, so it's in multiple data centers, and we have currently probably something like 7 nodes in that cluster. Yeah, so we already have 7 nodes running, so it's resilient. If the whole data center goes down, our online boutique is going to stay up, which is always helpful. And we also had this application, which we deployed into Kubernetes. I'm just trying to, yeah, this one. We also had this application, which basically was deployed into Kubernetes via containers. So every component was built as a container. And then we had these so-called Kubernetes manifest files, which described which container images to take, what ports to run them on, how to check that they're alive and stuff like that. So it's all declarative. You don't really write code imperatively to do this kind of thing. And this could have been like your little project for your startup. It's very easy to build infrastructure. Imagine if you had to do all these things by yourself, like with Linux VMs, you'd go insane.
I did that. I had a problem. I didn't know how to virtualize it, so I wrote some code and basically took 4 physical computers and connected them and tried to simulate what I tried to simulate. So I had a problem with physical network, so it wasn't configured for myself, so I had to configure it manually and do the boring stuff instead of coding. So yes.
And it's all doable, but it takes time, and you don't really want that. You want if you have an idea for a product or service, what matters is the delivery, is execution. What matters is time to minimum viable product, so to speak. And with this, it allows you to do this. But it's not just for small workloads. This Kubernetes thing can handle massive workloads. It can scale to thousands of nodes. And it can also, there is a thing called Ansys, which is based on that thing, on Google Kubernetes Engine. And Ansys can work on different cloud providers. So you can have some of your workloads deployed into AWS. You can have some of your deployments deployed to your on-premise physical servers. You can have some of them running in Azure, and they all come into single control plane, which is very nice. So, and Ansys is something unique, something that only Google has. It's this thing. So it basically allows you to have a consistent Kubernetes-based platform across everywhere, on-premise, other clouds, edge locations. Very, very, very hot topic at the moment. And the good thing about it, this has only existed for less than 2 years. So there is a really, really big shortage of people who can do this kind of stuff now. And as I said, companies are moving to the cloud at accelerating pace. And this is the stuff that they're going to use to move to the cloud, because it allows them to start locally and then move the workloads into the cloud. So yeah, this is why I think Google Cloud Platform is the best platform to get into at this moment in time. Yeah. Any other questions?
To sve? Ili ima neko pitanja? Da uđem u kadar. Questions?
You can ask anything really, even
imamo
related to technical things.
We have a question.
Yeah.
Možeš tu tako želiš.
Okay. So me and a colleague were just discussing, we aren't sure, what do those nodes actually present that you mentioned? So you mentioned, if I'm right, that you opened up 4 virtual machines, right? Yes, and 7 nodes. So why exactly 7, and what do those nodes actually do?
Okay. So we started with 4 nodes, are virtual machines, basically. But they don't have to be. They can be physical hosts in Kubernetes. In this specific instance, they are virtual machines. So we started with 4 because I think the way it's configured, that Terraform file, it asks to create a regional cluster, and that region has 4 different zones. So by default, unless I tell it otherwise, it just creates me a single VM in every zone in that region. This is how we got 4. Then when we started deploying the application, the application consisted of something like 10 different parts, and they're not the same size parts. Some of these microservices would be sort of more computationally intensive than the others, right? And as these applications were deployed, Kubernetes has figured out that the existing capacities, the existing 4 nodes, are not enough to run this workload. So it spun up more nodes. And with Kubernetes, you have very fine controls over how much computational resources you want your application to request. So you can basically say that my application would need at least this amount of resources. Or you could also say that my application should not ask for more this amount of resources. So you have very fine controls into how to provision stuff on Kubernetes if you want to. If you don't want to, you can just say it, well, if you need a node, provision one.
All right.
Does this answer your question?
Yeah, it does. So basically, if we don't know the exact number of nodes that we need, the program will do it for us, right?
You have two ways to do it. You can either say it, well, if you need an extra node, just spin it up, and then you run it, and you accumulate over time, empirically, you accumulate the information on how many nodes you need to run your production patterns, because it might be, and also the beauty of it, it scales up and it scales down. So if it scales up when the traffic is heavy, the traffic falls in the evening, the Kubernetes would drop those nodes without affecting the application really. So it scales up and it scales down. And once you know what your traffic pattern is going to be like, you can actually prescribe this in those Kubernetes YAML file deployment manifest. So Kubernetes would know exactly then how much resources your application needs.
All right, thank you.
So it's a bit of tuning, but that's what DevOps teams do. That's what teams in production do. They monitor the system and they adjust settings as necessary.
Yes. All right, thank you.
Hvala. Je li ima još neko pitanje? 1, 2, 3? Nema. Oliver, thank you so much. I think this was really useful to the guys.
I hope so.
Yes, it was great. I really enjoyed. We are always in search of pre-sales person, so I think I might reach out to you and steal your coding. Do some sales with me.
I just wanted again to emphasize that I'm sort of very open to answering questions, and if anybody would like to connect on LinkedIn, yeah, please feel free. And if you have questions you're not comfortable asking in public, you can ask me privately, and it's going to be private. So please feel free.
It's going to happen. It's going to happen for sure. So thanks a lot. We are really sorry that you couldn't come physically, but thank you so much for dedicating time yesterday and today to prepare all of this and to talk, even though you're not feeling your best.
It's all right. Thank you for having me. Cheers,
okay,
guys.
so bye-bye.
Cheers.